Hi students, this is Naveen. Today we are going to solve one more previous year question from capacitor concept. Here, let's solve the problem. A parallel plate capacitor has plate of length L and width W and separation of plates is D. It is connected to a battery of EMF V, a dielectric slab of same thickness D and dielectric constant given K is equal to 4 is being inserted between the plates of the capacitor. At what length of the slab inside the plates will the energy stored in the capacitor be 2 times the initial energy stored? Now we have to solve it step by step. First you have to take a parallel plate capacitor. This is the parallel plate capacitor. The parallel plate capacitor has plate of length L. Each plate of length L already given and width W. See, this is the parallel plates. If you see the side view of these plates, I will draw the side view of this plate, and here length is L. Here you can see the width W, and it is connected to a battery of EMF V. If these plates are connected to a battery of EMF V, till now it is clear. Now, a dielectric slab of same thickness D. We have to take one dielectric slab. I can take one dielectric slab here. This is the dielectric slab of same thickness. Same thickness means what is the thickness of the parallel plate? W. Here slab thickness also W, both are same. And what is the dielectric slab constant? Nothing but dielectric constant K is equal to 4, where K is the dielectric constant, is being inserted between the plates of the capacitor. If this dielectric slab inserted between these two plates, will the energy stored in the capacitor be 2 times the initial energy stored? Nothing but at what length of the dielectric slab placed between the two plates, the energy, nothing but the energy stored in capacitor doubled. First of all, you have to find out energy stored in capacitor before inserting the dielectric slab. Before inserting the dielectric slab, we know that what is the energy stored in capacitor formula? Already we know that U is equal to half CV square of, what is the C formula for parallel plate capacitor? C is equal to epsilon naught A by D, where A is the area of the parallel plate, D is the distance between these two plates, and for parallel plate capacitor, C is equal to epsilon naught A by D of into epsilon naught A by D V square. And from this, what is the A formula? Area of the plate before inserting the dielectric constant. A is equal to length into breadth. Here length of the plate L. What is the breadth here? W. Area becomes length into breadth. Area will be LW of multiplied with epsilon naught A LW by D multiplied with V square. Finally you got initial energy. Initial means before placing dielectric slab, the energy of the capacitor of epsilon naught LW by D V square. Now what they are asking, if you place the dielectric slab between these two plates, if I place the dielectric slab between these two plates, they are asking at what length. At here, let us assume this is L1. At what length the initial energy stored in capacitor is doubled. You have to find out this L1. Nothing but length of the dielectric slab. Which one you have to place it between the two plates. Let us assume if it is L1, remaining total length L, remaining length I can write L minus L1. It is clear? Now, after placing dielectric slab, what is the energy stored in capacitor? While I am placing the dielectric slab, here I can assume this is the capacitance C1 and C2, both are parallel to each other. After placing dielectric slab, the capacitance will be, capacitance C is equal to C1 plus C2. This is the formula for if the capacitors are placed parallelly. C is equal to C1 plus C2. Here C is equal to, what is the C1? C1 is here. We already know the formula, epsilon naught A by D. And here, if there is a dielectric constant, what it will becomes? It will becomes K epsilon naught A by D. Instead of A is the area of the dielectric slab. A is equal to, same here length L1 multiplied with W. Instead of A, I will write L1 W by distance D plus C2. C2 means this portion. There is no dielectric constant. What is the formula? Epsilon naught. Instead of A, I can write what is the length here? L minus L1 multiplied with W by D. It is clear? This is the capacitance of the capacitor after inserting the dielectric slab. But here, they already given K value. I can write K epsilon naught L1 W by D plus epsilon naught L minus L1 W by D. It is clear? This is the capacitance after inserting the dielectric slab. What about the energy? After inserting the dielectric slab, the energy I can say is the final energy stored in capacitor. Same formula of CV square of multiplied with C 4 epsilon naught L1 W by D plus epsilon naught L minus L1 multiplied with W by D. This is the final energy after inserting the dielectric slab between the two capacitors. After inserting the dielectric slab, this is the energy stored in capacitor. Before inserting the dielectric slab, this is the energy stored in capacitor. Now, what we have to find out? They are given one condition: at what length of the slab inside the plates will the energy stored in the capacitor be 2 times the initial energy? You have to find out. 2 times the energy means at what length? At what length the final energy becomes 2 into initial energy. This is the condition. In this condition, we have to find out the length of the dielectric slab. Till now it is clear? Now we are going to find out the length of the dielectric slab with respect to that given condition. Here I will take the data here. UF is equal to of, this is the final energy, of multiplied with 4 epsilon naught L1 W by D plus epsilon naught L minus L1 W whole by D, that is equal to 2 multiplied with of epsilon naught L W by D V square. It is clear? In this condition, we have to find out the length of the dielectric slab. This condition have to be satisfied. And here, what are the common terms? If you observe, here of both are cancelled, and here if you take d common, all these are cancelled, and what about the remaining things? And v square, here it will be multiplied with v square, v square cancelled, and remaining terms epsilon also common in both cases, epsilon not cancelled, and width also same, I will cancel, width also w. Remaining what I got here, 4L1 plus L minus L1, that is equal to 2. How to write this one? 4L1 plus L minus L1 is equal to 2. From this 4L1 minus L1, I can write 3L1 is equal to 2 into here, L is left, 2L here, 2L here plus L, it is transferred to this side, it will become L. From this L is equal to, from this L is equal to 3L1, but we have to find out the L1 value. L1 is equal to L by 3. If L1 is equal to L by 3, at that case the energy stored in the capacitor, nothing but initial energy of the capacitor before inserting the dielectric slab, it is doubled. It is clear? Our condition is satisfied. The dielectric slab length must be is equal to L by 3, where L is the length of the parallel plate capacitor, nothing but one of the plate of the given parallel plate capacitor. Like this, we have to solve the problem. Thank you.